Hello everyone, I'm with Don Balansat at Arizona State University, part of the Physics Instructional Resource Team, and I want to know about the properties of light and how we can manipulate them.
Okay, cool. So for those who don't know, light is this huge spectrum of electromagnetic radiation, part of which we can see. We call that visible light. And in general, light will go through three things as it travels. It can either be reflected, like a mirror, it can be transmitted, like a window, or it can be absorbed, like the color black for us. But the neat thing is that there are equivalents for that in every single part of the electromagnetic spectrum.
Okay, can you demonstrate that?
Sure thing. So first, we can change, in the visible spectrum anyways, visible part of the spectrum, we can actually change how much light is being transmitted through these things called polarizers. When we use a polarizing sheet, it's pretty much forcing light to travel in a certain direction. And these things I can do in out of phase directions, and what'll happen is when you see me do this is the light becomes blocked, right? And that would be absorption, or it would be absorbed by the material. It's interesting to note for us, the light is pretty much non-existent for our eyes, but the camera's probably picking up some blue because cameras, modern cameras in general, will be more sensitive to that wavelength of light. So,
okay, wow, so that's an example of absorption.
Absorption, yes.
Okay.
Yeah, through polarizing filters. Yeah.
And so what other examples can you show us?
So I've got another cool one right here.
Okay.
This right here is a thermal camera. It's made by Fluke. We use it to look at heat in buildings and stuff like that. But for now, we can just look at infrared light.
Okay.
So that's the part of the spectrum that's before red, infrared.
Okay.
So if you notice, if you want to hold up this it's not plexiglass, it's just a baking tray. For us in the visible spectrum, it's a window. We can see right through it. But in infrared, it actually blocks it completely. You can't see cyan anymore in the infrared camera. If you want to take it down real quick and so they can see you, there's cyan, and then back up, completely absorbed. Wow. So in infrared, this is like the color black. The glass is operating like the color black. Now, another neat thing is if you want to take that other prop we have there, it's just a black garbage bag. I think it's Glad. You can see it's black to us, which means it's absorbing all of the visible light that's coming into it. But in infrared, you can see cyan pretty clearly waving around. And that's just the way infrared will deal with this type of matter. So you can kind of imagine the possibilities with every single part of the spectrum and all the different types of ways we can manipulate it with different materials.
Wow, and you can also reflect it.
Yes, exactly. And we know it commonly like a mirror. And I do have a mirror right here. Right? And this is pretty simple. If I point it at the mirror, it'll reflect over to
oh yeah, so now you're lighting me up.
Right, even though I'm pointing it in a completely different direction, right?
Yeah. Oh wow, that's really great. And so it's really interesting and that's what we do is we figured out ways that we can manipulate the properties of the electromagnetic spectrum.
Right, to best suit our needs.
Okay.
Yeah.
That's fantastic. Thanks.
No problem.